Okay, we're going to move on to the next video where we look a bit more about, this is video 3, about HTTP, TCP, IP. And we want to look a bit more about how TCP works. And this link here was one I suggested to look at. This has basic information about TCP IP. This would be considered reading material. So you should read this before and or after watching the video. This is the page about the TCP protocol. Okay. First, IP. So if we look at IP, this is going to be information that's actually a pretty good picture there. So the information that's in the header here tells you about how it works. IPv4. Okay, so there is the header information. Basically, you have the IP address of the computer it's coming from and the IP address of the computer it's going to, and then some information about how to transmit it. So this is basically like you sending a letter, and then this is kind of the outside of the envelope here. Okay, so the outside of the envelope, and then inside of the envelope is something, and you send it, and that's it. Okay, that's IP. It's just has an address that it needs to go to, and it has an address that it's coming from, and then you send it along, and the next person that gets it will look at the destination address and try to send it in the right direction. So if you see that it's marked for a different state, then you would send it along in that direction. Okay, so this is IP. It's just has an address on it, and each person that gets it, each router or switch that gets it, is supposed to send it in a useful direction. TCP, Transmission Control Protocol, and the descriptors up here are that it's reliable, ordered, and air-checked. And that's going to be, there's a lot more going on than just putting an address on the packet. So if we look here, we have a source port and destination port. We're inside of an IP packet, so there's already information about which two computers are supposed to be involved here, the destination and the source. Now the source port and the destination port is for is so that there can be multiple different TCP connections on each computer. So here I see port 60071, but if I have another connection to, I would see eventually another port, so 60073, that'll probably be Firefox when I was refreshing Firefox. That's on a different port, versus the 60071 is the Telnet program. That's two different programs that are connected at the same time to KennyJeff.com. Alright, so we have that information, that there's something about a connection, and the sequence number and acknowledgement number is the main part that makes it so that the transmission of the information can be reliable and in order. So the rough idea of the sequence number is that this is supposed to, you could think of it as 1, and then every time there's a new TCP packet, it gets increased. If we look at, so let's go back up here. This was the beginning of my HTTP information. The total length of that was 1506, and if we look down here, it doesn't have the whole file. It sort of ends in the middle here, and so then there's going to be another TCP packet that sort of picks up where that one ends. So here we have text dash align. It would be GN would be the next. This is in the middle of a style in an HTML file. So that's GN, that's the first part of the data of this TCP packet. And this one ends with padding dash left. Next thing should be a T. There's a T as the first data byte in this TCP packet. And if we sort of look here, that looks like that might be the end. Back around, so nope, that's not the end. There's still more information coming. More information, and then this looks like maybe this one will be the end. Courses, nope. There we go. There's the end of the HTML. /HTML is the end of the HTML. So there's all those different parts that are supposed to be put back together to give a single file. And the reason that there are multiple parts is because you can't rely on the network switches and routers to send huge chunks of data for you in a single go. You could have them do that and it just wouldn't work out as well. So it works out better if they just send little bits at a time. So this is 1506 is the size of the whole packet. Now the actual amount of information is less because there's this header information. Okay. So the sequence number would roughly say which one of these is supposed to be first. This is the one that should be first, right? So if we look at this inside of here, we'll see a sequence number. So there's 1. And it says relative sequence number, and we'll say what that means in a second. But if we look at this one, this is 1441, relative sequence number. So we would think that this should be like a 2. So there's a 1, there should be a 2, then there should be a 3, then there should be a 4, 5, 6, 7. Okay, that's not exactly what's happening, and we'll say what's happening in just a second. But that's what the sequence number is supposed to be for. What's happening here is you don't want to exactly send 1, 2, 3, 4 because of the possibilities of attackers sending fake data, and we'll talk about that in a little bit. And this acknowledgement number is the reliable part. So the sequence number is needed so that you can take little pieces and put them back together. Okay, IP doesn't do that. IP is like you send a bunch of separate envelopes and there's no way to know which one is supposed to be first. The TCP, you number your envelopes. That way they can be, it's like you're sending a page in each envelope. And then the envelope has the number. All right, now the acknowledgement is used so that the person that sent the information can be sure that it was received. So if I send an envelope in the mail, I don't know if it was received. So what happens here, you'll see going back and forth. Here's an acknowledgement. There's an ACK there. And this is going the other direction from my computer to kennyjeff.com, where there was something said that there was something that basically says, yes, I received that information. Okay, that's basically what the acknowledgement is supposed to mean. And let me pause the video for a second. Okay, now about these sequence numbers and ACK numbers, acknowledgement numbers. Here is the TCP page, And if we look here, protocol, operation, connection establishment, there are 3 things that are supposed to happen. So there's a SYN, a SYN-ACK, and an ACK. And if we look over in Wireshark, there's a SYN, a SYN-ACK, and an ACK. And it all starts with the client. So this is the client, me, talking, sending information to the server. So what's supposed to happen here is the client picks an initial sequence number that's picked at random, and that's done for security reasons. Okay, so security, there's a sequence number, and this says 0, and it says relative sequence number, but then highlighted here is 105F E2B4. Okay, so that's a random sequence number, and Wireshark is just calling that 0 because it's smart enough that it knows that that's what it's supposed to mean. All right, the other side is supposed to respond with a SYN-ACK. So synchronize and acknowledge. So it acknowledges the A by sending back A+1 in the acknowledgement field. So let's see. We have a that ends with a B4, and now if we look at this one, in the acknowledgement field, there's a B5. All right, and this says relative, it's subtracted off the random value. Okay, so the server responded with A+1 in the acknowledgement, and it picks its own random B for the sequence number. So the sequence number that it picked at random is this, and Wireshark is calling that 0. So now the server knows that the client connected, and it's sending back the response, and the last bit to establish a connection is the client will send back to the server to say that it got its value. So the client can confirm that it got the response from the server by replying with the random value that the server picked, +1. So if we look, so the random value that the server picked was this thing that ends in C8. The client responds with something that ends with C9 in the acknowledgement field. Okay, so what the sequence number is supposed to mean is this is the next byte that I will send. It will be the 0th byte. And the acknowledgement number is supposed to say this is the bytes that I've already received. So at the beginning, I haven't sent anything. This is going to be 0. So what this thing is going to be 0. I also haven't received anything. Okay, now the server responds and says, okay, I haven't sent anything, but this is going to be my random value that means 0. And so far I have received nothing. The next thing I'll receive is whatever that random value you picked +1. Okay, so now the client responds and says, the next thing that I'm going to send is the 1th byte, right? That's just the random value I picked +1. And the next thing I'm going to receive from you is your random value that you picked. Okay, now this is the first byte of actual information, the first bit of actual information. If you look at these, this one here, for example, if you look at the TCP, that highlights the TCP header information, and after that would be the data. There's no actual data here. This is just header information. This is real data that was sent back and forth, but there's no actual content from Firefox or from Telnet. So this is before when I was over in Telnet. So this was when I typed Telnet, trying 192 whatever, connected. So this, before this connected would be displayed, this is what had to happen, these 3 things. And then the Telnet knew that there was a connection. Okay, so here's the first thing that, so this is when I typed get, and this gets sent to the server. Alright, so let's look at the sequence number. So the sequence number here is 1, and this note here says next sequence number is going to be 27. That's because there must be 26 bytes of actual information here. So the sequence numbers are counting the bytes. It's not the number of packets, it's the number of bytes. Okay, so this says the next sequence number should be 27, and that's really this value plus 26. So the sequence number sent, so that's the server. So this is, we went from sequence number E2B5 at the bottom there to E2CF, which if you do the conversions, that is 27, 26 more than B5. Okay, and in between there you see an acknowledgement coming back from the server that says, yes, I received that. The next thing I'm expecting is byte 27. So that is the sequence number sent here plus the number of bytes is going to be the acknowledgement that was sent back. So the acknowledgement is always the next byte that you expect to receive. And the sequence number is always the byte that you're sending right now. Okay, so there's 1, and then there's 27, and then there's 48, and I believe that is the end of the GET request. No, let's see. Yeah, that's the end of the GET request, and then the server is going to respond with the actual data. So it's going to be coming the other direction. So this is the actual data coming, and this is the first actual data coming from the server. When I was over in Telnet, this information was sent out. So that's going from Firefox to the server, and then this is what comes back from the server, all of this. Alright, so there's a sequence number of 1. The next sequence number, 1441, that says that there's going to be actually 1,440 bytes of actual data. And this says TCP segment size is 1440, and that's calculated based off of, okay, the total size of the information here is 1,506, and you got to subtract off the TCP header size and the IP header size and the Ethernet header, which we haven't said much about yet. Okay, we were looking at the sequence number. So the next sequence number is supposed to be 1441, and there it is, 1441. It's not actually 1441, it's the random value that the server picked plus 1441. They're going up by 1441. There's acknowledgements coming back, so that acknowledgement says that the client, so this is the client, it's going the other way. This acknowledgement says the client has received up through byte 2880. That's another acknowledgement. Then so the sequence numbers, this is going from the server to the client again. Sequence number is going up, and the client responds with the acknowledgement that says it received. And what happens, so this acknowledgement was supposed to ensure reliability. What happens on the server is if it doesn't get an acknowledgement after a certain amount of time, it'll send it again, assuming that it must have been lost. And there's some choices that have to be made about how long to wait and how to resend packets, but that's what the acknowledgement is there for. So the client is responsible for sending these acknowledgments periodically. Let's say I've gotten this number of bytes. Otherwise, the server will resend. Okay, so there's a lot of, let's see, where's the header? There's a lot of other information that goes in here about options and algorithms that get used for what happens when you don't see things. So this pretty much looks like it was received in order, which it looks like they were. They're all the packets are received in the right order. There's no mistakes in the packets. This is the easy case. So there's a lot that goes into what happens when they're received out of order, the sequence numbers. So if they're received out of order, the sequence numbers are used to put them back in the right order before giving it to Firefox to display. And the acknowledgement numbers and the sequence numbers together make it so that the sender will know if the receiver didn't receive the data. Okay, that's TCP, and that is on this picture here. So we have TCP, which is the part that deals with reliability and sequencing, and IP just is for keeping track of where an individual packet is supposed to go. So the network interface in the physical layer we haven't talked much about, but I will say just a tiny bit. So each of these packets here has, so if I look here, this was the original request from the client to the server, and we had the IP with the IP address, and we had the TCP part with the ports. Now above that is an Ethernet information. If we look inside of the Ethernet header, we have a destination and a source and an IP version. And if we go over to the Wikipedia page that has all the, we originally were at Internet Protocol. Internet Protocol there's TCP, and underneath that is IPv4, and underneath that is the link layer. And if we click on Ethernet, then we'll see a header here again eventually. Perhaps, let's see, frame structure. So we'll click on Ethernet frame. All right, here we go. Here's a header. Let me pause. Okay, so if we clicked on the Ethernet, so this tells us there's two layers that are displayed here. If we're looking at this one, this is showing what happens. The payload is the actual data. So with respect to the Ethernet header sits up here, and the data is everything else. Before that, we're supposed to have an Ethernet type. So that's 2 bytes. So the 2 bytes there is 0800, which is code for the fact that what's inside of there is going to be an IPv4 packet. All right, and then we have a source and a destination, which are 6 bytes each. And the source and the destination, those are MAC addresses, media access, whatever MAC stands for. Okay, but that is the 6 hex character code that's supposed to be unique to every Ethernet card or router. So this is the MAC address of the computer that I'm using right now, and this is the MAC address of the wireless router that I'm connecting to. And some routers will have a feature that you can turn on that will limit connections to only certain MAC addresses. So then this MAC address, this one here, which you can get by looking in your, well, you can look online for how to find your MAC address for your wireless or other network card. So this would be the one that you would put into your wireless router configuration if you wanted to do that. Now the fact, if you look at this here, this is information that's being transmitted from my computer. Right? All of this information here is being transmitted by my computer. So looking at the security side, just limiting my router to accept connections from, say, this MAC address is not going to be a very secure thing, because my computer is sending this information. If somebody had a device to capture all the wireless traffic coming out of my computer, they could just park on the street and listen, and then if they had the right software, they would see this MAC address. This is all not encrypted. The inside information, right, whatever's inside of this TCP packet, this could be encrypted, this part. But typically, the Ethernet information, the IP information, the header, and the TCP header is all sent in the clear. But, so that's the Ethernet header information. Just has this, this is supposed to be unique to every Ethernet card. So this is outside of the DNS system. So there's no IP addresses, there's no KinneyJeff.com. This is just a 6-byte number that's supposed to be unique for every device that could be connected to any kind of network. Okay, so that's TCP IP over Ethernet. If we look at this, we go to Internet Protocol, we have looked at TCP, IPv4, Ethernet, and you'll read through this information, and we were looking at TCP, IP over Ethernet. And Wireshark is the program. And we'll have a homework 2 that will do something with that.